Hi, Paul the AirSweep guy here to talk about pneumatic flow aids, and specifically the difference between fluidizing discs and air sweeps. Now over the years I get the question quite often, what is the difference between a rubber fluidizing disc like this one and an air sweep? Well, there are some similarities, but there's some major performance differences, and we're going to take a look at that right now. So these rubber fluidizers are meant to provide gentle vibration and a little bit of aeration of powdered materials. They install from the inside of the hopper, they pass through the wall to the outside, and they're held in place by a retaining nut. Air piping or tubing would be run to the inlet of the fluidizer, and the actuation would be controlled by either a ball valve or solenoid valve. When the fluidizer is actuated, the air runs through it and is forced between the vessel wall and the rubber disc, causing the disc to flap and vibrate and air to radiate out. Now the combination of gentle vibration and aeration causes the product to activate and flow. Now this is effective with bakery flour or cements or any kind of light powder that will easily aerate. Not too effective with stickier materials or heavy materials. Now there's generally more than one of these units in the bin. They'll be all chained to one ball valve or one solenoid valve to operate in unison when flow is desired. The air sweep is installed from the outside of the bin by cutting a hole in the vessel wall, welding a coupling, and threading the unit through. A lock nut holds it in place, and a solenoid valve would be placed on the back of each air sweep. The only thing that's inside the vessel wall is the air sweep piston itself. When the solenoid valve is actuated by a PLC or timer, the piston head pops open for a quarter second, disperses air in a 360-degree pattern, and then instantly reseals. Now there's usually more than one air sweep in the bin. They'll be sequenced separately, so in a linear sequence, one followed by the next by the next. The timing of that sequence will depend on the material being handled and the process. I've put together a demonstration that illustrates how these devices differ in performance. Let's go take a look. A key difference between the air sweep and the fluidizing disc is going to be volume. The air sweep uses a 3/4 inch line running into a 3/4 inch solenoid valve, so at 60 psi there's a lot of volume running through this line in instantaneous bursts. The fluidizing disc is using a 3/8 inch line, and it's actually going into a 1/4 inch port, so a lot less volume, even at the same pressure, can come through this. It's kind of the garden hose versus fire hose analogy. A fire hose running at the same pressure as a garden hose is going to deliver a lot more power. We're going to see that in the demonstration right now. So we've put together this test board and we've installed a VA06 air sweep right here. Now this is the working end of the air sweep, the part that would be inside the vessel wall. And we've marked with 1 foot increments around the air sweep. And we're going to surround the air sweep head with these hex nuts. These weigh about a 1/4 ounce or a little less each. And we're going to surround the head, we're going to pulse it, and that's going to show us the activation radius, or the area of influence that the air sweep has over the material. Afterwards, we're going to try the same thing with the fluidizing disc, and we'll compare. Let's do it. So we got about 1.5 feet, maybe a little more, and about 1 foot over here activation radius. That's the amount of material that was displaced by the pulsing of the air sweep. And that was pulsed at 60 psi. We pulsed it twice. The second pulse really didn't do anything. The stuff was all displaced with the first pulse. So now we're going to try the fluidizing disc and see what happens. Okay, we've got the fluidizing disc installed, and we're going to go ahead and put the nuts around it and give it some air, and let's see what happens. Let's do it. Okay, so we can see about a 6 to 8 inch radius, maybe a little more over here, maybe about a 10, that's maybe about a 6 at most. So we didn't get too much of a radius of activation around the air pad itself. So when we compare the two activation radiuses, we really see that the AirSweep can push the heavier material a lot further, a lot faster. And again, that's a function of volume. The volume running through the AirSweep in that instantaneous burst carries a lot of power. The fluidizing disc is made for light materials, fluffy materials, not heavy, granular, sticky product. I hope you found that interesting. Remember, the fluidizers are effective with light, fluffy materials that can respond to gentle vibration and a little bit of aeration. The AirSweeps can handle those materials, but can also handle the heavier, stickier, wetter materials. So if you've got a bin that's seeing a lot of different kinds of materials or seeing environmental changes where the humidity level changes, you might want to consider something like the AirSweep over a simple fluidizer. If you have any questions, please feel free to email me at paul@airsweepsystems.com and visit our website at www.airsweepsystems.com. This is Paul, the AirSweep guy, saying, keep it flowing.